Hi friends, we're going to take a look today at how a disease spreads through a population and what we can do to protect that population. So we're going to start with a little story, so check this out. It began with Naoko Yamada. She and her family had just moved when she started the second half of her junior year at Western High in a small town in Washington State. 1 week into the semester, she had a sore throat, felt exhausted, and developed a fever of 102. Soon, she had a red rash all over her body. Ugh, measles. 10 days later, Caleb Miller and Jessica Johnson came down with measles. These students were in Naoko's biology class, and Jessica was her lab partner. The following week, a sophomore, Michael Chen, had measles, and so did the student's biology teacher, Miss Baker. The local public health officer was alarmed. Western High hadn't had a case of measles in 10 years, and now there were 5 cases in less than a month. What do you suppose could have caused that type of outbreak? Brainstorm a couple of things, like, could it have been that they weren't exposed to the measles virus? Could it have been that Naoko, carried it from Japan? With the ease of travel, a lot of times people move, travel, go places, and they don't know that they're sick until they get there. So when you think about some of those factors that might contribute, now consider this. After a little bit of sleuthing, they found out that Naoko had just arrived in the United States from her home country, Japan, where she apparently contracted measles. She had not been vaccinated as a child. Caleb was also susceptible to measles because his parents had objected to vaccinations. Jessica and Michael were vaccinated when they were 15 and 18 months old, respectively, but they had missed the required booster shot during elementary school. So Ms. Baker was vaccinated in 1966 when she was 5 years old. Later studies showed that the initial killed measles vaccine was not very effective compared with the currently used live measles vaccine, which wasn't even first available until 1968. Ms. Baker was unaware that her vaccination was not effective or that she even needed a booster shot. The results of the public health officer's detective work, which is basically what an epidemiologist does, explained why Naoko, Caleb, Jessica, Michael, and Miss Baker got the measles. But there's another question. In the 1950s and 1960s, before the measles vaccine was developed, most people got this disease as preschool children or as elementary school students. Interesting. So, how is it that it used to be very, very common in the population, and now it's not? Well, that has to do a little bit with what we're going to study today. So the next thing that we're going to do is we're going to we're going to spread a pathogen in class, obviously in a safe manner, so nobody's actually going to get sick. So this is what I need from you. At this point, can you make sure that everyone in class has a copy of the graphs as well as the little cards? There should be red construction paper, yellow, and then black. I'm sorry, yellow? What am I talking about? Red, pink, and black. Thanks. Pause here and then make sure everybody has their stuff and then get started again. On your first graph, you're going to label one of them Simulation 1 and record 0% immune and 100% susceptible. At this point, none of you have ever had what we are calling the 2-day disease. So make sure that your cards are set up where the red card is on top, the pink card is in the middle, and the black card is on the bottom. Now, what we're going to do is we're going to be trying to make contact with other people in class. And we're going to see how that pathogen spreads throughout class. If at any point in time 25% of our class is sick, that's going to mean that there's an epidemic level of that infection. And there's my dog with her little squeaky toy. That's fun. So do me a favor and take a line or draw a line across that number, that 25%, for however many people are here in class today. And that's going to be the epidemic level. So, you know, the goal is, obviously, we don't want more than 25% of the population in class to get sick. But it might happen. So let's find out how this is going to work. So you're going to have to record in that little chart on the left-hand side of the graph how many people are sick, so how many red and pink cards there are, and then how many people are immune, so how many black cards there are. So somebody in the middle of the room is going to volunteer to go first, and they're just going to say, I'll go first, I'm going to be sick first. So somebody volunteer, and what's going to happen at this point is that person is going to hold up their red card, and this is going to designate day 1. So on day 1, you get sick, you've got the infection, you're contagious, you've got your symptoms. But during day 1, you're going to only make contact with one person in class. So from where you're seated, reach out and touch somebody else in class. Now, day 2, the person that was our index case number 1, is going to switch to the pink card. Why do I keep saying yellow? I have no idea. And the person that was touched now holds up their red card. So now we've got 2 people that are sick in class, and nobody's immune, right? Now, on day 2, though, both of these people are still contagious. So they both get to reach out and touch somebody else. Yay! At this point, let's pause the video, and then you can move on and finish the simulation until the disease has run its course. Make sure that you are recording the number of people sick and the number of people immune each day. Great. So now that you've done that, did everyone in class get sick? Was there anybody that was left untouched by this disease? Interesting. Now, that's kind of like what things were like until we understood the way the immune system works. So we're going to run a second simulation. So what I need you to do is take a look at the second graph and check this out. Label the second graph Simulation 2. And 50% of our population is going to start out as immune, and 50% is going to be susceptible. So quickly, in your heads right now, calculate how many people that would be if 50% of our group is going to be immune. There's a set of white cards. Some of them say immune, some of them say susceptible. Would you please count out the number that would equal 50% of the class? And then go ahead and fold them up and kind of spread them out up front. And everybody come up front and pick up one. Keep it to yourself, though. Don't let other people know if you're immune or susceptible. Go ahead and pause right now. Awesome. So everybody should know now if they are immune or if they're susceptible. So what we need to do is run the simulation again. So reset your cards, red on top, pink in the middle, black on the bottom. And somebody in the middle volunteer and say, I'll go first because I am susceptible. So that initial index case is going to reach out and make contact. Here's the problem. We don't know who they're going to touch, and we don't know if that person is immune or susceptible. So if you are immune and you get touched by somebody that is sick, you're going to immediately pull out your black card from the bottom of the pile and hold that up. So for day 1, we're going to have our index case that is sick. And then 50% of the population is immune. So you are not starting with 0 immune on this second simulation. Go ahead and now let's see what happens for this simulation. Pause now and run the simulation. Great. So at this point, did everyone get sick? Or, interesting, did you even reach epidemic levels? Now, I want you to consider, why is it that not everybody got sick? What happened? Did you notice? Those people that were immune were actually protecting those people that were susceptible. And it's kind of like being in a herd, like a herd of cattle, right? And those cattle are protecting you if you're on the inside of the herd. Now, I totally forgot what I was going to say. The dog started squeaking again. Sorry. Still don't remember what I was going to say. That's okay. Herd immunity. That's the whole point of the whole simulation, Mrs. Learned. So this concept is called herd immunity, H-E-R-D, immunity. And the idea is if you can get a certain number of the population that is immune, it will protect those people that are susceptible. So in our class here, even though we only had 50% immune, potentially from vaccinations, maybe they've had the 2-day disease before, I don't know. And even though those people were safe, they protected those people that were susceptible. So now think back to that situation at Western High. And I want you to flip over your graphs. Once you've completed both graphs, make sure that you do that in 2 different lines. You're going to do one color for the number of people that are sick and one line for the number of people that are immune. Use a different color. So you can use my markers, you can use my colored pencils. And then flip it over onto the back. And then I want you to consider these questions. Why didn't the unvaccinated or inadequately vaccinated students and teacher at Western High get measles when they were children rather than now as teenagers or adults? Why is vaccination not only a personal health issue, but also a public health issue? In your response, would you please use the term herd immunity and kind of write it as a paragraph, if you will. When you're finished, you can take that sheet with both graphs and your response and turn it into the basket. Make sure that your name is on it, and you can move on to the next post in Classroom.